Hi guys, my name is Vivek and in this video tutorial we are going to talk about bitmap and bitmap join index. I have a small request. If you have not subscribed to my channel already, please go ahead and do it now so that you get a notification as soon as I upload a new video tutorial. Now let's understand what is the purpose of bitmap index. Bitmap index and B-tree index share the same performance, which is to expedite the performance of queries. So for example, you have a table in your warehouse or database that has millions of rows, and there are certain queries that access few columns on a regular basis, maybe in your reports or in your ETL process. You want to go ahead and index those columns so that you get performance benefits in your queries. Now let's go ahead and understand what is the basic difference between bitmap index and B-tree index and what kind of index should be chosen in what kind of situation. So bitmap index and B-tree index are different in a manner how they store data. B-tree index stores data in tree format, while bitmap index, which we are going to discuss today, it actually stores data as two-dimensional arrays. Bitmap index are created on low cardinality columns, while B-tree index are created on high cardinality columns. Now what exactly is a low cardinality column? A low cardinality column is a column that has less number of distinct values in a table. So for example, I may have a million rows in my employee table, but the column gender will contain only a few distinct values. It can be male, female, and the same goes for marital status as well. There can only be a few number of distinct marital status. Either the person can be single, married, divorced, or widowed. So though these two columns will be present for every row in the table, but they will have only few distinct values. So a low cardinality column has very few distinct values, and bitmap index are actually suitable for low cardinality columns. B-tree index are the exact opposite. They are actually suitable for high cardinality columns. And guys, I just want to repeat, if you have not watched my videos on B-tree index, I'll drop a link in the description. Go ahead and watch these videos as well. They are really going to help you out. So when should we go ahead and create bitmap index? So I've already explained the first condition, that you should have a low cardinality column. The first condition is actually a very common condition. Whenever you search for bitmap index, the first thing that you will read is that you should go ahead and create a bitmap index on low cardinality column. I mean, it's not that you cannot create a bitmap index on a high cardinality column. It's just that it's going to consume a lot of space if you're trying to create a bitmap index on a high cardinality column, and we will understand the statement as we proceed. The other condition, which is actually very vital, and a lot of people don't understand this or don't know this, that you should not create bitmap index in an environment where the process or the table can be updated by multiple concurrent processes. This can actually lead to serious performance and deadlock issues. So guys, we should create a bitmap index only if the data is being modified by a single process at a time. If you anticipate that your table or your data can be modified by multiple processes at the same time, creating bitmap index is a strict no. That's why we don't create bitmap index in OLTP system, because OLTP system are prone to multiple updates in parallel. Bitmap index are suitable for large data warehouse where we don't have any parallel updates. And guys, write this down. You never want to create bitmap index in an environment where you have multiple concurrent updates. It's going to lead to severe performance and deadlocking issues. In today's world, you can still go ahead and create a bitmap index on a higher cardinality column, but never create bitmap index in a situation where your table can be updated by multiple concurrent processes. And we will understand in a moment why this can actually lead to serious deadlocking issues when we see how the bitmap index is actually stored on the database. And guys, this is one thing that I've noticed not many people understand about bitmap index. So hopefully after this tutorial you will understand what are the locking challenges with bitmap index and why you should not create bitmap index in a situation where the table is being updated by multiple processes. So here we have an employee table where we have the column ID, first name, middle name, last name, mobile number, date of joining, designation, salary, marital status, manager ID and department ID. Now guys, I want you to pause this video for a moment and try to evaluate that out of these columns, which columns are actually suitable for creating bitmap index and why. We have already discussed the prerequisite condition for creating a bitmap index. Just try to judge that which particular column should be a part of bitmap index. So I hope that you were able to answer this particular question. Let's see if your answer was correct. So the ID column is of high cardinality. It has lot of distinct values. In fact, every single value is distinct, so it does not fulfill our first condition that the column should be of low cardinality. The same goes for first name, middle name and last name as well. They are almost unique. Even the mobile number is actually unique. The same goes for your date of joining as well. Designation is actually a good candidate for bitmap index because in an organization you can have only a handful of designation. A person can be an associate, an engineer, a marketing professional, a executive, CEO, CFO. So there are only so many roles that a person can take. So a lot of time this question is being asked that how many distinct values should be actually considered good for low cardinality. So if your number of distinct values are in single digit, double digit or triple digit, I will consider them that they are in low cardinality, given that you have a lot of rows in your table. Now again, salary can take any value, so this does not have low cardinality. Now marital status has only 3 values: single, married and divorced, so they are low cardinality. One can argue that you can have a limited number of managers as well, so you can consider that into bitmap index. But this is a gray area. You can have a lot of managers in a big organization, so I won't say at this moment that this is a low cardinality column. But yes, department ID is again a low cardinality column because you can have only so many departments in an organization. Now let's see how the data is being actually stored in bitmap index. I mentioned earlier that while B-tree actually stores the data as a form of tree, the bitmap index stores the data in a form of 2-dimensional array. So here we have the table, and obviously I have minimized the table just for better display. It has this 3 columns: ID, gender and status. So if I go ahead and create a bitmap index on gender column, it will actually be stored in the form of this 2-dimensional arrays with 2 columns, male and female, and it will only store 2 values, 1 and 0. Let's see how it's going to work. So for the first row, the gender is male, that's why we have 1 in front of male and 0 in front of female. So in the 2-dimensional array, when the value is actually present for that particular column, we will specify it as 1, otherwise we will specify it as 0 bit. So for the next one, it's actually a female. So you see here we have 0 bit in female and 1 in male, and it will happen so on. There is one other good property of bitmap index, that multiple bitmap index can actually act in conjugation to deliver faster results. Let's see for the other status as well. So here we have single. So we have specified 1 bit in single, and we have specified 0 in married and divorced. Then we have divorced in second. So we have specified 0 in single and married, and 1 in divorced. Now let's say that if I try to go ahead and create a bitmap index on my ID column as well, it will actually result in a lot of zeros. So ID column is a high cardinality column. Only one column in a particular row will have 1. Rest all the columns will have 0 values, and to store that amount of data, my index will consume a lot of space. That's why you don't want to create a bitmap index on a high cardinality column. It will cause data or storage issues for you. Now let's see, if I write a query and I try to identify single male, how it's going to work in the background. So in this particular table, I want to identify single males. So the first thing that it will do is it will identify in front of male where I have 1 bit. So I have these 5 values, this and this. So I have these 5 values in front of where I have 1 byte, and then it will try to anticipate that out of these 5 males which are single, so only the first value is where I have 1 bit in front of male and single. So instead of traversing the entire table and doing a full table scan, it will quickly retrieve this data and send it back to me. Let's understand this with another example. Now I want to identify the female that have been divorced. So the first thing Oracle will do is it will try to identify out of all the records how many are female. So here we have 4 females that have 1 bit corresponding to them in front of them. So these are the 4 females, and then it will try to identify out of these female which are divorced. So it will go to the divorce index and it will see where we have 1 in front of them. So these 2 records, record with 2 and 4, they are both female and they are divorced. So it will display the row ID corresponding to these values and it will fetch the data corresponding to these rows. So that's how the bitmap index actually works. Now guys, this is actually very important to understand how locking works in bitmap index. As I've already mentioned that if your table is being updated by multiple processes in parallel, you will have serious deadlocking issues. Let's understand how that's going to work. So in order to understand that, let's create an index on the column department in my employee table, and this is how it's gonna look like when we create a bitmap index. For each department in employee table, you will have 1 or more entries in the bitmap index. Each entry in the bitmap index points to potentially hundreds of rows. So if you see here for department number 10, we have 2 entries that actually points from a low row ID to a high row ID. It has these many values, and the bitmap actually signifies whether a particular row belongs to that department number or not. So this particular first row in the chunk does not belong to the department number 10. The second row actually has the department number 10. The third row has the department number 10, and so on. Now guys, please pay attention carefully. We have a situation where an employee is moving from department number 10 to department number 20. So earlier his record belonged to this particular chunk where he was part of the department number 10. Now he is moving to the department number 20. So guys, there is a lot of confusion on how bitmap index takes an exclusive lock on the entire table. This is how it actually works. So when we try to update the employee from department 10 to department 20, and it belongs to this particular chunk earlier, and now it's going to this particular chunk. So this particular entry and this particular entry will be in an exclusive lock mode. You cannot modify any other entry. At the same time, let's say a different employee from department 20 is being moved to department 10, but these two are already locked. That means he will have to wait. Now let's say another entry is trying to add an entry in the department number 10, which is to be added in this particular entry. That will also have to wait for the completion of the earlier 2 transactions. So understand guys, if this particular table is being updated by 15 different transactions at the same time, they will all go waiting for the earlier transactions to commit, which will result in a lot of deadlock and performance issues. That's why it is actually a prerequisite that you don't create a bitmap index on a table, on a column that is being frequently updated by multiple processes. Guys, actually note this down and analyze this in your projects as well. If a bitmap index is being created on a table, it will be a low cardinality column, and that table will not have frequent updates if at all. And this actually applies for inserts and deletes as well. So if you are having updates in parallel and there are processes that are trying to insert or delete the data. So for example, if employee from department number 20 has left the organization, then we will have to update the bitmap index as well. We will have to delete his entry, which will again require an exclusive lock, but the entries are already locked by other transactions, so you will have deadlock issues. So just go ahead and visualize in your projects as well. You won't find too many bitmap indexes, and when you have bitmap indexes, they will be created on columns with low cardinality index, and these tables will be updated as a part of batch processes only. So these are some of the important things to remember when we talk about bitmap index. Bitmap indexes are available only in Oracle Enterprise Edition. Since I'm running on Oracle XE Edition, I won't be able to create a bitmap index, or if you have installed Oracle XE Edition on your machine, you won't be able to create a bitmap index on your machine. It can only be created in Oracle Enterprise Edition. While generating a query plan, the Oracle can actually use multiple single bitmap index together in a query. You can also create a composite bitmap index on multiple low cardinality columns. So the way we created composite B-tree index in our earlier videos, similarly you can create a composite bitmap index as well on multiple low cardinality columns. Now I have a question for you guys. In our previous examples, we had two low cardinality columns on which we created bitmap index. Do you think it will make more sense to create two single bitmap indexes on those columns, or do you think it will make more sense to create a single composite bitmap index on these columns? Give your answers in the comment sections, and we will discuss that what is the better option and in which condition we should use multiple single bitmap index or composite bitmap index. Two important things that you have to remember when you are creating bitmap index: never create bitmap index on system where table can be updated in parallel by multiple processes, and Oracle actually recommends that you create bitmap index on columns with low cardinality only. So the syntax of bitmap index is pretty similar to B-tree index. B-tree is the default or conventional or the oldest index. If you just specify create index, by default it creates a B-tree index. You don't have to specify a keyword for the B-tree index, which is not the case with bitmap index. In bitmap index you have to explicitly specify the keyword bitmap. So if you specify create bitmap index, index name on the table on which you want to create the index and the column name, it will go ahead and create a bitmap index for you. So here in this statement I'm creating a bitmap index, and that's the index name department employee IDX on employee's department number. So it will create a bitmap index on the column department number of my employees table. And guys, bitmap indexes are actually very helpful in data warehouses. They are very helpful in aggregation. For example, I want to evaluate the revenue generated by single men living in North America. If I have created bitmap indexes on my gender, region and marital status column, I can actually use that index to evaluate the rows or to evaluate the transaction done by single male in North America region. Instead of doing full scan, it will use these particular index, thus giving very faster results. So in data warehousing environments where the updates are infrequent and the data is inserted as a part of a batch process, we will see that the bitmap indexes will be created on low cardinality columns. So let's talk briefly about bitmap join index. While bitmap index is actually created for a single table, bitmap join index can be created on join of two or more tables. Though the index will belong to a particular table, but it will store the values that are retrieved from the join of two or more tables. And as we move to our next example, this will be very clear what I mean to say. The other thing is that it's a space efficient way for reducing the volume of data that is to be joined. And again, when we move to our next slide, this will be very clear what exactly is meant by it. In data warehousing environment, the join is an equi-join between primary key of dimension table and foreign key of a fact table. And guys, whenever we are talking about fact table and dimension table, the fact table constitutes the primary key of the dimension table. If you are still not clear about fact tables, dimension table, I have made a couple of videos on star and snowflake schema and on data warehousing. I will highly recommend that you go ahead and watch those videos. I will drop a link of those two videos in this particular video tutorial. So just to rephrase, bitmap index is created for a single table. Bitmap join index is created on join of two or more tables. It's a space efficient way for reducing the volume of data that is to be joined. And in data warehousing environments where we create bitmap or bitmap join index, bitmap join index is actually an equi-join between primary key of the dimension table and foreign key of the fact table. So let's understand what exactly this means by this particular example. So we have two tables. We have a transaction table and then we have a customer table. So our transaction table has like millions of rows, and we have quite a few rows in our customer table as well. The transaction table, which is my fact table here, it has the primary key of the customer table, customer ID here, but it does not have any other attribute. So let's try to understand this particular query. Here we are trying to identify the amount of revenue generated by customers who are male. That is what we want to obtain from here. What we have learned earlier, that since gender is a low cardinality column, we can create a bitmap index on this column. So first of all, when the Oracle execute this query, it will identify that which particular customers are male, and then on the basis of that it will join it with the transaction table and retrieve the results. So it will still have to join the customer table and the transaction table in order to retrieve the results. This is what is avoided using bitmap join index. So what we will do is we will create an index on the join of these two tables. Here we have created a bitmap index and this is the name of the index. Guys, the important thing to note here is that the syntax of bitmap and bitmap join index is the same. We don't have the keyword bitmap join, it remains bitmap. So here we have created a bitmap join index, and see, the index will be maintained with the table transaction, but we are storing the value of customer gender. So in the layman terms, if you want to understand this, it's like adding an additional column to the transaction table virtually. Here we have the equi-join. Customer ID is the primary key of the dimension table customer, and it is joined with the foreign key in the transaction table customer ID to retrieve the value. So behind the scenes, what will happen? We will have a bitmap index generated. So this transaction row ID 1, it's being performed by male. And how exactly this index was generated? So let's go back to our table. The transaction ID 1 is being done by customer ID 1, which is Vivek, and he is a male. That's why we have this. The second transaction is being done by customer ID 2, which is Sonam and is female. Transaction 3 is also done by Sonam, which is female. So we should have, for second and third transaction, we should have one bit in female, which is the case. So this index is created in background, which means as soon as we go ahead and run this query again, instead of joining these tables, it will directly retrieve the values using this particular bitmap join index. Now guys, though bitmap join index can be really powerful, it can give you almost 8 to 10 times improvement in your query performance. Having said that, you need to be really careful when creating your bitmap index. All the existing bitmap index restrictions apply on bitmap join index as well. That means you should have a low cardinality column. And guys, I have a question for you. Try to identify the term what is degree of cardinality. So again, you should have low cardinality columns in bitmap join index. You should not have concurrent updates. Some of the other restrictions that are there, that the parallel DML is currently only supported on the fact table. Parallel DML on one of the participating dimension table will mark the index as unusable. So you cannot have parallel DML on dimension table. It's allowed only on fact table. Only one table can be updated concurrently by different transactions. So you have concurrency issues. No table can appear twice in the join, so you cannot have one table in the join twice, and that kind of stuff. So while creating bitmap join index, you need to be really careful and really certain how it's going to help you out. Let's do a quick recap of bitmap and bitmap join index. Bitmap index are different from B-tree index in a manner of storage. they are implemented on low cardinality columns. And the most important thing is, never create bitmap index in OLTP system or on a table that can be updated in parallel by multiple processes. This will lead to heavy deadlock and performance issues. So hopefully guys, this tutorial was informative and you learned what is bitmap index, what is bitmap join index. If you still have any doubts, just let me know and I'll try to answer as soon as possible. Thanks a lot guys for watching this video, and I'll see you in the next one.